Alright, let's go ahead and start in on the camera controller. The camera controller script itself is already written. What we want to do is walk our way through the code itself, make sure that we understand how the camera works, so that later if you want to add to the camera, if you want to change things up, you'll be able to do that with it. If you go inside of Unity in the Project tab, you'll want to open up either Scene 1 or Scene 2. We're just going to use the character and the camera there in those scenes. In your hierarchy, you should see a camera. Just click on the rollout for it and see the main camera. In your inspector, if you scroll down, you should see a component called Camera Controller. Inside of the, if you click on this, you can either get to your scripts. For instance, my scripts is the Camera Controller script here. You can either double click on it or open it up through your project, clicking on the Camera Controller. So once it's set up, what we want to do, again, we just want to take a look at how it works. We'll go ahead and play this real fast just so you can see the setup for it. The idea is that the character himself is going to be able to rotate freely without having the camera do a follow behind. There's a standard follow behind that's already been created, which is great. This one's kind of nice because then you can rotate around and see your character from different views. If you're using a joystick, you've got the left pad for player movement, you've got the right pad for camera rotation. The rotation that you do with this camera is going to be based on a speed. We're going to take a look in a second with the actual script on this side, but just so you understand how it's working is that if you do have just to make mention of, if you don't have a joystick and you have keys, you'll be able to use the J, K, L, and I key. The keys themselves inside of Edit, if you go down to your project settings and input, the input options are going to be the last two Camera X and Camera Y options. Now those two, you'll notice, have the J and L and K and I. If you want to switch them, if you like inverse or non-invert, you can switch those around. The options for gravity, dead, and sensitivity, these are the changes that you want to, if it's not made, be sure that you do make. Otherwise, it'll spin too fast when you push the key. So you want to set those to 1000, 0.001, 1000. Same one for the camera Y as well. So set those two up if they're not already set, and then you'll have good smooth control using your keyboard as well, so you don't have to use a joystick if you don't want to. Let's go ahead and click back on our main camera. So the main options inside of the camera is going to be the target. The target doesn't have to be the player himself. For instance, our target for the Mario character is actually a camera target right here. And so you can set the camera target to be potentially further in front of the character, lower, higher. It just gives you a little bit more free reign for how the character, for how the camera is pointing to the target. Also, for the target, there's a target height. Let's go ahead and just kind of show this real fast. The target height is actually designed so that you can scroll it up and down, and this moves just simply the target itself, the target height itself, and allows you to have a different rotation point. Not necessarily needed for just the standard game side, but maybe you want to change it or adjust it due to a trigger event or something occurring. You might want to set it up that way. The next one is your collision layers. Your collision layers, they're designed just so that we have we're going to use the line cast that's sent out, and it's going to check for any objects inside the scene. If it hits the object, it's going to take it from the current distance to a corrected distance. For this one, we currently have collision layer set for ground. The ground setting is so that when the camera actually goes down towards the ground, it zooms into the player. Notice how it jumps below the scene. Sometimes it's going to happen, and that's going to be, you can actually fix that from our offset from wall, and we can set this offset amount higher. That way it doesn't even get down to that level, and we'll take a look at it in a second. The other option again is that we can go in here and set we'll do this one real fast. We can set a cube inside the scene, for instance. And if we were to scale this up, say we wanted to just make a wall in our scene. If this was tagged, say we want to say it's a wall, for the camera, we'll just make sure that our collision layers gets added to. We'll now look for a collision with walls as well. So again, the basic idea behind this is that if the character becomes occluded between camera and the object, it'll jump in as close as it can to see the player. It's currently set up to be pretty rough. It's nothing that's going to be amazing. It just simply jumps in. There's a lot of different ways to handle this for smooth movement, for fading out the object in between the line cast. There's a lot of different ways to approach this, but what we're doing is just keeping it with a very simple side of it so you can see how that's set up. Also, let me set that target height back down so it goes to the normal. There we go. Alright. So if we have the camera set up, we've got our basic character and our collision working with it. We'll move our character out so you can see collision. So it's going to get in, notice it's going to push out, and go back out. Alright, so we have our collision layers, we have our distance, which is going to be the standard distance away that we want to make the object be. And that one, this is the distance between target and camera. The speed, X speed and Y speed, this is for how fast the controller for the rotation around with the camera is moving. The higher the value, the faster it's going to move. The slower the value, the slower the camera. These are, again, X speed is horizontal, Y speed is vertical. There's a minimum limit and a maximum limit on our vertical limit, on our vertical amount. That way, the camera can't just simply go 360 degrees around this way. We want it to stop at the top, and we want it to stop basically at the bottom. The X direction, notice it does spin all the way around. So we're just simply setting a limit to the vertical side with it. Your rotation speed, this is just going to be simply how fast the rotation is going to be going around. It's added to the X speed on it. I think it's actually added to the Y speed as well. Your zoom min limit and zoom max limit, this is how quickly the camera zooms in and out between the pieces. When you hit a collision object, it'll zoom in or out. And then there's a dampening speed for the ease of it when it zooms in and out. You also have the offset from wall. Again, this is the distance away. If we were to set this one up just a bit more, say for instance we set it up to about 1, that way when the camera comes down, notice that the camera actually stops at this height. I can't take it down any further. So we can set things to be much further away from an object, which reduces in the clipping. There'll be a lot less clipping visible if you have that distance, but you have to be careful on how much you pad it, because if it's too much, then you may have issues with being able to go between objects with the camera. Alright, and then the last couple are going to be private variables, which will be where we store our input values for the get axis on the X and the Y. Let's go ahead and get back out of here. So let's go ahead and go into our functions. We'll take a look at those and just quickly discuss them. Alright, so overall this whole thing is only 88 lines of code. It's pretty small in terms of having a collision system and having the camera rotation, movement, and all of that. So getting started with the late update, we're just calling this up after the player animations have performed a movement. The get axis is being called based on also being calculated in as the speed for the X and the Y. We have a clamp value for the Y. Now remember, our clamp value is this is going to be a clamp angle. This is a function we're writing down here at the bottom. So we'll just kind of jump down from here. We're wanting to keep our angle of our camera on the vertical between 2 points. We're looking for a minimum and a maximum limit. Inside of the function that we make here, this is just simply grabbing up the angle currently and checking whether it is less than 360, greater than, and then adding to or subtracting from. And it's returning the angle, min, and max. Alright, so with that one, we're able to actually say that if we wanted it to be, we'll just do a quick show for this one. Say for instance I want my maximum limit to actually be somewhere around, we'll say like 40, 45 or so. If I wanted it to be around here, that means that when my camera gets down here, let's see, I'm not going to be able to rotate any higher than that. So if I wanted to set it down to even something lower, Maybe we want it to be just behind the player. We might set it to say 20, which means I restrict it even further. So now this is as far above as the camera can go for the player. Alright, so you're able to adjust those pretty easy and set up your own system for it so that you can find out what works for you. Go ahead and close this one. Jumping back into here, once you have the Y set to the clamp limits, this is going to make sure that you don't receive anything greater than or less than those limits. The next part of this, here, we'll set this up so you can see them as well. The next part we're just doing is setting up a variable to store the rotation. This is just going to be storing the slurp between 2 points. The 2 points is going to be your the camera's rotation currently, and then the Euler angle of the Y and the X based on the time and the delta. This is going to help us for our rotation of our camera. We have a vertical target offset. This is going to be just a vector 3, which is going to start. It's basically going to allow you to store the target height. That way, we know how much we can actually offset from the object. The next part is that we're just going to take our position. The cool part about this one is we're taking the position is going to store our all of our parts and pieces together. It's going to store the current rotation. It's going to store the current forward direction, the desired distance between the two that it's trying to get to, plus the amount offset from the object. So we've got a lot of things that's happening right in here, but we don't have to really worry about it. It's just handling it in one line. With this right here, you have the control of your camera. What we want to do next, once we have the basic control, we want to go ahead and say, okay, now if we want to check for collision, we want to say, okay, well, before we finish it off and assign it to the actual camera down here, let's check to see if the object's being included from anything else. So for this one, we set a raycast hit to just the word collision hit. This could also be just used as hit. What it's going to do is check to find out if there is a line cast, if it can see between the target and its current position. If it can see between these, then it's fine. It's not actually going to be moving. It's not going to try to correct its distance. However, if the collision layer, the value that we are currently using, if it's, for instance, we say if it's checking for a wall and it actually sees a value tagged with the layer on the wall, then it's going to say that yes, it actually is being corrected, so it has to move from that position. Alright, so the two ways that we're checking for this, we're going to be checking for if it is corrected as false, so that, meaning that the distance between the two isn't moving, it's fine where it's at. If it is, then it's just going to continue a standard lerp between the two distances. However, if it is false, that means it has to be corrected. If it's true, it has to be corrected, so the current distance is going to equal the corrected distance. Okay, so a simple statement, and just remember the corrected distance. This distance right here is being pulled from right here when your physics line cast is when it actually gets a value that's true. If it becomes true, it's grabbing the distance between the target and the collision object. Okay, so then it's going to set it from the offset, which means it's going to be moving it inward. Alright, so this is also just kind of a point out, this is just one direction. You could also have a different way. Instead of just saying, okay, if I can't see it anymore, move it inward. Well, you could also say maybe check to see if I can move up. And if up is an option, maybe move up instead. You could also say to fade out the texture so that the object in between gets faded, and just set the alpha to go down on it. A lot of different ways that you can approach it. This is just a very simple way to go through it. Once you have that one, you go down to the bottom part here. Let's pull this up so you can see it. Alright, so we want to take the current distance, and we're just going to say that our current distance, we're going to clamp it between two values, and what we want it to be is the current distance, the distance where the camera is located, and then the zoom min limit. Now remember, our zoom min and max limit right here, this is how close can the camera get to, how close can the camera object get to the target object. And this is the maximum limit out, how far away can it go. Alright, so what we're doing is setting the clamp between those distances right there. And then once we've established that, then we can actually set the position to equal our current target position based on the new current distance from it. So that's going to allow us to have the correct position for the camera. And then the last thing that we want to do is actually assign it to the camera. So we're going to make the transform rotation position. This is the camera's transform rotation. We're going to set those to the value of the rotation and the position there. Alright, now hopefully this made some sense to you. It's just basically walking you through what's happening inside the script. It's a very, like, if you wanted to pare it down to what it what it actually needs to be for basic controls, you're looking at this set of code right here, and you're looking at setting the code right here. You don't even need that part. You could just do this part, and you would still have the same functionality, just without the collision detection to work with. Alright, so that is the basic setup for our camera controller for the scenes. Some of the scenes that we're going to be working from may not have the camera turned on, or may be using the smooth camera. If you're wanting to use this camera, just double check inside the inspector when you click on the camera option, and make sure that the camera is actually checked. If the camera is unchecked, you can just check it, and then you'll have the access to it. Again, remember, to be able to move the camera around, it's going to be I, J, K, and L. That'll allow you to rotate the camera up and down on the keys. Otherwise, you can use the joystick and have the same control with it.